of you. I'm sorry, and I'm really sorry not to be there. And first of all, I would like to thank Sarunas and you and the organizers for inviting me, because this is a theme that we really think it is important, and we are really happy of talking and working in this kind of activities about inclusion, and we think it's really important. I am Alessandra Zanazzi, and I work at INAF, the Italian National Institute for Astrophysics, which is the institution that the research institution in Italy researching about astronomy and astrophysics, but also we have a strong commitment in public engagement, in communication and dissemination of scientific culture. And our idea is that this public engagement should be as inclusive as possible, that an inclusive approach should be the standard in designing education and outreach activities. Because the idea is that it's well known that everybody, regardless of any impairments, but everybody, each of us has a different way of being curious about the universe and a different way of learning, different intelligences, different kind of approaches and interests. And so we feel we have a duty, I would say, of being inclusive, of trying to include and interest as many people as possible, to use different languages intended of way of approaching, way of engaging people. And so what we are now trying to do every time that we think about a new activity is to use a universal design approach. Universal design means designing activities and events so that they have the maximum possible usability without adaptation or special support. So the idea is that if we have an activity, we should head, let's say, at the no barriers approach. We should try to the maximum possible extent to project them so that there is no need for support as much as possible. Of course, we know that activities that are good for all, for everybody, it's an utopic idea. It's not possible, but nevertheless, we can try and do our best to the maximum possible extent again, okay? So I wanted to give you some examples of this in our opinion. The first and more, I will talk about a permanent exhibition that we inaugurated in the half of 2019. So unfortunately, we had the pandemic since then, and that, like you know, of course, blocked a little bit of the possible activities. Anyhow, this is an exhibition that we made here in Arcetri at the observatory, which is universally designed, let's say, in a way that is for everybody, but is thought so to be inclusive also for blind people. And the exhibition is hosted in the visitor, let's say, area of the observatory, which is this dome here, and this is the interior of the dome with the old historical telescope, 150 years old, we have here in at the observatory, and that we still use for communication activities, for outreach activities, for outreach purpose. And we included in the exhibition activities that were already published and made by other observatory, other researchers. So we used already existing material like, of course, the beautiful material of the project, The Touch of the Universe, that was developed at Valencia Observatory. And for example, we had 3D print tactile models of the moon, and also tiles of the far side and near side of the moon. In what sense this is universal design? In the sense that it's of course usable and touchable for blind people, for visually impaired, but also it has proved to be very useful for any visitors coming to the observatory, because you can touch the tiles and you can feel and you can immediately imagine and understand the difference between the two sides, and the fact that the far side is not as much protected as the near side, and so it's more rough and full of craters and these sort of things. And this is something that it's immediate for everybody to understand. As well as, for example, we had 3D print, we printed with a 3D printer also some models of the domes of the different telescopes to understand the scales, let's say. So this black one in the center is the small, very small in proportion dome of where the exhibition is hosted. This is the Observatory Amici dome of the old telescope. And so everybody can see just at a glance, or can touch, the differences in the dimension to scale of the VLT, and this is the LBT, the Large Binocular Telescope, just to understand the proportions. As well as we made, thinking about this exhibition, nothing new, I mean, nothing particularly innovative, but what we think it is important is that this string, for example, which represents the distances in the solar system, could be we use it with all the school students coming and visiting the observatory, for example, since we made it for the exhibition, because this is very immediate, very the beads are all the same size, so you can concentrate on the distances only, and you can see how far away are the far planets in the solar system, for example. Also, for example, we made this thermoformed panel representing the H diagram, because this is especially printed by the Associazione Nazionale Pro Ciechi, which is the pro-blind association foundation, the national foundation. They, of course, have a strong experience in researching and representing different textures in order to be recognizable at touch, but also we colored it with different colors so everybody can see. And what we wanted to do, and what we thought it was important about this exhibit, let's say, is that we could also talk about a little bit more complex issues and things and astrophysics, not only planets and telescopes, because we think it is important also to go a little bit deeper, and so we have Braille but also color, so everybody can use it, can take advantage of such an exhibit. And the very, very, very like say exhibit we are really proud of is the tactile planetarium dome. We made it with quite easy to find and to reproduce ingredients. The recipe for the tactile planetarium dome is a transparent plexiglass dome, 1.2 meters, that the biggest one we could find ready-made. I think we bought it from a factory that produces for the public illumination, public lights or something like that, and we found it already like it is. Then we used red strings to mark the celestial parallels and celestial meridians. This is my colleague Niccolò Bucciantini. We did it together. I mean, and we positioned the parallel and the grid so that we could use it to position the stars and reproduce a night sky. And then we put it the stars. We marked the star using stellarium prints of the different areas of the sky, and we did prints from magnitude 1 and 2, then magnitudes up to 3, then magnitudes up to 4, and then up to 5, so that we reproduce the stars correctly with great, attention to the real position. And there was, we needed, of course, a little bit of patience. It was some days' work, but not so much as we thought, actually. It's feasible, it's easy to do. And as for the representation of the stars, we discussed it a lot, and then we decided to use beads for the fainter stars up to magnitude 5, half pearls for the magnitude 4 stars, wall pearls for magnitude 3, which were like 80 and 200 stars respectively, and then 30 stars magnitude 1 to 2, represented by one wall bead and one half bead. So the idea was that the stars with different magnitude are modeled with different aids of the star, not making them bigger or smaller, because in this way we decided not to propagate, let's say, some visual misconceptions that comes when you look at the night sky. A lot of people has the impression that the bigger the star, the more brilliant they are, and so that the luminous star necessarily are the bigger, because this is what we the sort of a visual misconception that we get. And so we decided to avoid the visual misconception, which is quite an advantage, of course, representing the luminosity, apparent luminosity of the stars with the height of the representation of their representation, so that it's a completely different parameter, and it's not leading to any confusion, so to say. So the stars up to magnitude 5, which were, I think, thousands of them, we did not reproduce all of them, but only the one that were needed to conclude, let's say, the drawing of the constellations, so to recognize them. This is the dome in its final position, which is in a room close to the dome of the historic telescope. You can see that we put some guides on the wall so that we could lift and lower the dome depending on the necessity to use it or just to sit around it. So it's quite easy and simple, but really effective, because what we noticed is that we tested it with blind people. This is the inaugural event, and what we realized is that it was a qualitative testing, but nevertheless, we were able to see that after, let's say, a guided tour of the night sky of the dome, people could recognize by themselves. Blind people could recognize by themselves again when they finished the tour. They could find the constellation, and that that was really powerful, and also we were really happy about that. But also it is nice to look at, and it's you know, a lot of people or children coming and visiting, they are really curious and attracted by these objects. So it's a way of involving and engaging them as well. Of course, future developments foresee more testing and evaluation, even more quantitative, because we're beyond qualitative, more exhibits implementing the exhibition, of course. And in particular, we have been working at a multi-sensorial version of the dome. We have a dome in the Institute of Radio Astronomy in Bologna, and we are working with my colleague in Bologna and Padua and other observatories. We are working together, and the idea is that of reproducing non-optical astronomical sources also, because non-optical astronomical sources are often radio sources, for example, the radio sky or microwave sky. They are represented visually normally, the data. But there is no need actually, because this is not visual data. So we thought about using interactive devices so that to involve different senses, different sight, touch, hearing, for example, using sonification or sound, anyhow, different sounds in order to represent different information. The problem here is it's quite difficult to avoid over stimulation, let's say, sensory confusion, and so in order to do this, to avoid this, we are starting up collaborations and want to work together with other experts, like, for example, cognitive psychologists, sound designers, and of course advocates and people with difficulties, so that we can test it with them. Is also it works also with everybody. It is really inclusive and working in that way. Last, I would like to just mention another couple of other examples of universal design we have been involved with. And the first one is not an INAF project, but INAF participated to the production of this. This is a planetarium show made by Newcastle University and the University of Portsmouth in the UK, with the funding from the Science and Technology Facility Council and Royal Astronomical Society, and collaboration with the Istituto di Astrofisica di Andalusia e l'Istituto Nazionale di Astrofisica. And this show is unique in its way, because it has been tested with blind people, and the testing it also been quantitative. Data are still under study, but it was tested also before producing the show. And the show, the innovative thing I think is that it started from not from images, which is what normally planetarium show do, but started from sounds, from sonification data. There were scientific data represented through sonification, and in this way, the sound is core part of the experience of the show, and the show is freely downloadable at the website in different languages. Sure, it is English, of course, Italian and Spanish. I don't know if they had it but anybody, if I'm pretty sure that if anybody wants to translate and adapt to different languages, you can do it, and it can be freely downloaded and used in any digital planetarium with different systems, projection systems, I mean. And there is also a flat screen version, which is of course less effective, because the thing is that you can, in an immersive situation like in a planetarium, you can hear sounds representing stars and planets with different sounds. You can hear them moving across the dome, coming from different areas of the dome, different directions. And so, for example, you can learn about the sun pattern in the sky, and hearing the sound coming from different distances, of course. And this is, of course, more effective in an immersive environment. And the second example, another example, is a research project we are working together with the CNR, another Italian institution, is about the Italian language, sign language. We think that this is quite an important and universal design approach, because of course it is inclusive in communication for deaf people, because they use the Italian sign language and they know and they speak, let's say, the Italian sign language. But since it is such an iconic representation of words, that it could be really effective also, of course, in terms of raising awareness of diversity, of the diversity, in this case, of people using the Italian sign language. But also, it could be a way of deepening astronomical knowledge and the tradition and the astronomy connection with the culture and with the tradition. Because, for example, in this case, this is a video that is made speaking I don't know if you say speaking, but using the Italian sign language, and he is explaining why the word moon is made like this, indicating the face. And he says that you can use this sign because during the full moon phase, the moon looks like it is a face with like a human face with eyes, nose, and mouth. And so the sign for the moon is like a human profile. So we can learn and interest people and engage people learning about the Italian sign language, and then we can also use and create maybe new signs that are not present, and this happens in every sign language all over the world. The sign language is not universal. Each culture, also locally, they change a lot. And for example, this is also connected to an International Astronomical Union project, which is about creating a sort of a repository of a glossary of signs in different languages, and starting with 47 signs selected by a commission of experts, has the most commonly used in teaching and popularizing astronomy. Yeah, I think that this is it. I have finished my time. I hope I was in time. I cannot hear any anything. But anyway, anyhow, I wanted to thank you, and this is my address. I am happy now to to discuss any comments or any question you may have. Also, if you want to write them to me, I will be happy to answer.